All right, guys, so we are going to do section 6.3 notes. And before we start, I just want to talk about the fact that this is going to sound very familiar and very similar to what we did yesterday in class. So before I even start, I want to talk about the difference between what we did and what we're doing, okay? So yesterday, what we were given, it's all about what we're given, all right? So yesterday, what we were given is that we were given a parallelogram. And then from there, we could use those 7 properties, all right, to make conclusions, okay? So we were given that it was a parallelogram, and then from there, we knew those 7 properties, okay? Today, what we're trying to do is we're going to be given a quadrilateral, and we have to prove it as a parallelogram, okay? So today, what we're doing is we're talking about the ways of proving quadrilaterals as parallelograms. And there's 5 different ways, okay? So for the first way, all right, what it says is if opposite sides are parallel, then parallelogram. All right, and I'm abbreviating this, all right? We could say then it's a parallelogram, all right? But if opposite sides are parallel, then I know it's going to be a parallelogram, okay? And when I say opposite sides, and I'm condensing this, all right, it could be a much longer theorem, but what I'm saying here, if opposite sides, it's if 2 sets of opposite sides are parallel, all right, then it's a parallelogram, all right? So I don't know if you want to put that in there, all right, but if 2 sets of opposite sides are parallel, then it's a parallelogram, okay? All right, the second one is if opposite sides are congruent, then it's a parallelogram. So if I could prove that the opposite sides are congruent, then I know it's going to be a parallelogram, okay? All right, the third one is if opposite angles are congruent, then it's a parallelogram. Okay, so if opposite angles are congruent, and again, it's if 2 sets of opposite angles are congruent. And then the fourth one also sounds very similar, and this one's about the diagonals, all right? So if the diagonals bisect each other, then it's a parallelogram. And so I'm going to pause there because all 4 of those sound very familiar, all right? They were all properties of parallelograms, and now we're just switching them into methods of proving it as a parallelogram, okay? The 5th one is different, all right? And I'll draw a picture of it to show you what I mean. But for 5, hold on.
Any 10th graders that are in the building that need their picture retaken, please report to the auditorium at this time.
So I started writing, all right, but it says if one set of opposite sides are congruent and parallel, then it is a parallelogram. Okay? So it says if one set of opposite sides are congruent and parallel, then it's a parallelogram. So if I just come up into this white space right here and I draw a picture of a parallelogram, if I could mark the sides as both parallel and congruent like that, do you see how they're on the same side? All right, then I can state that that's a parallelogram. All right, and they have to be on the same side. You can't split them apart and have that those 2 sides are parallel and then these 2 sides are congruent. That's no bueno. All right, you can't do that, okay? So you have to have it so that those are along the same side, okay? So those are the 5 different methods, all right, of us proving it as a parallelogram, okay? And so for this next section, it says, does the given information permit you to deduce that the quadrilateral ABCD is a parallelogram, okay? And we're going to do all of these. There's a ton of them, okay? So the first one says, and I'm gonna have to be like writing on my parallelogram and then I'll erase it. But if it says that if AD is parallel to BC and AB is parallel to DC, is that enough information to state that it's a parallelogram? And the reason is yeah, all right, yes it is, because of that first reason. If the opposite sides are parallel, then it's a parallelogram, okay? Now, the next one just gives us that AB is congruent to DC. All right, and the answer to this one is no, because you need to have both sets of opposite sides are congruent. All right, they only gave you one of them. All right, next one says angle ABC, so this full angle is equal to angle ADC. All right, and again, the answer to that one is no, because I only have one set of opposite angles are congruent, and I need to have both sets, okay? Okay, now D says if I have angle DAC, all right, so watch this notation here. So angle DAC is congruent to angle BCA. And then I have that angle BAC is congruent to angle ACD, so this one right here. And so right away, students are kind of inclined to say no, you know, but it's not that simple, because if you think about chapter 3, all right, you have to identify what type of angles these are. So if you look at these two angles, what type of angles are they? Well, they're alternate interior made by these two lines cut by that transversal. And what do we know about lines that make congruent alternate interior angles? We know that those lines have to be parallel. So if we use that same logic, all right, and I now look at these two angles right here, and I look at the lines that create them, all right, cut by the same transversal, that means that these two sides are also parallel. So using that alternate interior converse, all right, the answer to this one is actually yes, all right, because we know that the opposite sides are parallel. Okay. All right, let me erase all of that on there, and let's go to the next one. Okay. All right, so this one says angle BCD, so this angle right here, and angle ABC have to add up to equal 180. Well, that does tell us one thing. So if you think about, again, chapter 3, all right, I have these two lines, all right, and then I have this transversal. And those are same side interior angles. And what we know with same side interior angles is if they're supplementary, then these lines right here are parallel. But the issue is that we don't know that AD and BC are also parallel, all right? And we also don't know that AB and DC are congruent. So that's not enough information, although it was an interesting application, all right, to proving that the lines are parallel. All right, F says AE is half of AC. So that means that these two segments right here, AE and EC, would be congruent. But again, that's not enough information because the diagonals have to bisect each other, all right, which would mean that we would also need, all right, that the other two segments are congruent, which brings us up to this next one right here. And this one says that AE is equal to EC and then DE is equal to EB. And now that I have both sets of segments are being bisected, all right, the answer to this one is yes. Okay, last one says that I'm given AD is parallel to BC, and I'm also given that they're congruent. And then this one is going to be yes through that last method of saying that one set of opposite sides are both congruent and parallel. Okay, so I'm going to pause here and then come back to do some algebra.